Hello everyone, welcome back. Hey A2Y. How did the earlier stream go? Quite well, I'd say. We didn't get to the actual WASM stuff though, except for discussing what the current state is, because we're fixing the more general problem of too many ASM blocks in modules we ship. So we're trying to get rid of some of them. We're making progress on that because the hardest one for me was the lock comp exchange assembly instructions, and we now have an intrinsic for that allows us to use the LVM in bytecode. Not the LVM, the LVM IR operation for locked comp exchange. Cheers, by the way. And that gives us the possibility to do this properly, hopefully, on all platforms. But we haven't tested it yet. But it works on x64, except that our own x64 backend doesn't support it yet. This is what we have to do next. Well, not quite next. The next thing is to do the comp exchange at runtime properly, I think. So here we do, let's do all the versions. And hope that that's fine, which means we need to run the intrinsics code. This one. No, not this one, the other one, intrinsics. This one we have to run at compile time to see things failing, I think. Let's just try the comp exchange. So let's do all the versions. Let's do A is 5, B is 7, R is 5, and do lock comp exchange, R, A, B, result, assert result is 5, assert R is 7. Okay, and now let's do this. And we say type is T, and all of them are T, and so we say S8, U8, S16, U16, etc., etc. 32, 64. Okay, and then let's do a separate one with pointers. We say this is a pointer to int, whatever, let's say, no, let's keep this one. Let's say int, which is the default, so we can just skip this one actually. Oh no, let's make it explicit. And then let's say pointer r is r, a, b, b, and actually this points to a, and then we do let's pointer r, pointer a, pointer b, and also I want a bool test here. Oh no, that doesn't work. This is all wrong. This is a type and this is T. Boy, I can't program. Okay. And then we can actually do the generic version. So we make sure that this is val A, result is val B. We don't do the negative test here. We never try the does it not exchange if the values are different. That's tested somewhere else. This is just to make sure that we do all the types properly. With the generic version now, we could say true, false, 5, 7, 5, 7. Maybe we should pick higher values for the other tests, but I don't care right now. Well, maybe we should. Let's try the U32 version with FF, 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 and FE, 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 FE. Just for fun. And that's too many Fs. And Fifi. Okay, just to make sure that we do the sizes kinda maybe correctly. Okay, now we could use this as well for if we do that. And we say pointed to A, pointed to B, and it's pointed to int. That should now work as well, right? Right. Hey, Berkoff Lord, Siberia. Yeah. Greetings to Siberia. Here, procedure call doesn't match any of the possible overloads. Yep, that's what I thought. So the bool doesn't work. I want the comp exchange to work on all the types, all the primitive types at least. Can we do this without an intrinsic? We could do the test enum. You know what? If we take this one and put it here, we can also do the test enum test. Let's make our life a bit miserable. Okay, because now we need a, I'm not sure if we really want to support this, but now we would need definitely need a templatized version. All the others we could do explicitly. This one we can't do explicitly. Okay, let's leave the simple one here for now. Oh, by the way, maybe it's a good time. I found a new chocolate. Short break before we actually try this. So this is currently my all-time favorite one, but it's crazy expensive, like absurdly expensive. So I buy it relatively infrequently. I recently discovered this one, which costs less than half of the other one. I've tried this a bit. It's good, but I want to compare it. Like, this is still unopened. I want to compare it to my favorite, to see if it's worth a crazy amount of money. It's been a while since I had this one, so. Hello, Vancouver. We're covering the whole Earth. And with the whole Earth, I mean like Asia, Europe, and North America, which I know is not the whole world. But still. Of course you let it melt. Okay. So we have the problem that our intrinsic is not polymorphic right now, but maybe we should just do that. It seems a bit intense to do this polymorphic though. Not sure if that actually... if that's a good idea. But that's what I want. Let's see what that does. It did not blow up immediately. Okay, bytecode runner complains. That's fair because it doesn't have these. This one is very, very good. I'm gonna wash it down with a bit of matcha. So we just have assertion failed false. What? What? Tests, features. And let's try the other one in comparison. It has a very nice packaging, by the way. As in, on the inside, you have another paper wrap, and the outside is resealable. Not resealable, but at least you can close it back, which is nice for something that you eat over a longer period. Like this is not the kind of chocolate where you just put the whole thing in your mouth in one sitting. At least I don't. Okay, and what we complain about? Assert false. Number flag 0. Oh, I should have... Yeah, whatever. Good, the number flag 0 is because that's on the pointer. And I knew that this was going to happen. So if we look at... we don't see it here. We should see that is of a pointer type. Oh, it's Boolean. Okay, Boolean also has no number flags. Okay. So we say if not number flags. And we had this somewhere else. I think with the binary operations. Yeah, this is the code we need. This one I wanna see in the debugger though before I do anything. This is not left def, and this is old value def. So what, you just fail? Oh, this one failed. 107. So it's not actually in the compiler. No, great. It's the Boolean case that fails. The result is not value A. What? Let's make my life easier by doing the compile time, the runtime version. That just worked. Seriously? Okay. I want confirmation of that. Call me skeptical. All okay. Wow. Okay, so our polymorphic version just works. We're gonna try something nasty. We have a big struct here. Did I just see this right correctly? No. So we have to make sure that this creates a compile error, which it probably won't. I think we're just gonna barf. Didn't mention any of the possible overloads. Oh, because of the comparison. Ha! Also, let's make our life easier by pulling this out, so we don't have the order problem of internal scopes, not internal scopes, imperative scopes. Now it should still not crashing. Yeah, because I'm bad at this. Probably can't see this one. Now it just runs. Yeah, and we boom. So this one needs to be caught. At compile time, preferably. So we go to the byte builder and we say we have to check here. How do I get the size? Maybe we do it in the typer. Though, I'm not sure. Okay, so for the chocolate comparison, more important, the more expensive one has a nicer texture. Like the cheaper one is slightly grainy and like sandy. Not really sandy, but grainy is probably the best word. But taste-wise, I'm not sure if it's like. It's definitely worth paying half the price. No, it's not chalky. It's just the other one is completely smooth, and that like this one. And this one, you have well, small, yeah, sandy, grainy. I don't know how to say it. It's not smooth. You have tiny. You feel lots of tiny chunks. But apart from that, it's pretty good, and it's definitely worth paying half the price, I think. Okay. Yeah, the problem is I'm not sure I want a modify on comp exchange. I might be able to, but I'm not sure. Like a modify without a body, I don't think we have that anywhere. So this might stress the compiler in different ways. So I don't want to have a special case in the typer just because I want to have a modify here. I'd rather just do this in the compiler. We could do it in the typer, which would be easier. But we can do it in the builder, I think, where it makes more sense to me because here is the, like here we compare against log comp exchange, which we don't do in the typer. Like if we look for in, like we never check which intrinsic it is. Okay, so I don't want to introduce the fact that, hey, this is a certain type of intrinsic. I don't want to do this in here. If we have the special cases for the intrinsics here, I think I'll do the check here. I'm just not sure. For the intrinsic, okay, it's an array of asked, so I can just say, okay, that's actually fine. So I can say here, this, and can say if all value defn size is not 1 and not 4, oh no, 2, 4, 8, then we do report error. On argument list 0, lock comp exchange only supports arguments of size 1, 2, or 8. And I should say currently. But not blah, and here we put old value defn size and now I have to do the stupid macro nonsense. Right, what's the stupid macro? This one. Comp exchange R. Lock currently only supports argument of size 1 to 4, but not 16. Yeah, and we put it here. Shall we put it on the cold call, maybe? Maybe let's use site. Because it's strange to have it on the pointer, basically. T-spec struct. Yeah, you get the full context of what type of this was, where the comp exchange. So we're generating a polymorph of this. It's triggered here. This looks good. Okay. Is there any way of sending in a size of 3? Yeah, sure, totally. We could say this should barf as well. Okay, so we don't have an equality for that, but we can say here you go, struct of size 3. And I'm too bad at this. Yeah. Currently supports argument size 1, 2, 3, 4, or 8, but not 3. Okay. So this one should still work. Yep. And now we have the problem that this one doesn't exist. Boom. Because the x64 converter doesn't yet know about that stuff. And this is something we have to put in here. And now it sucks that I'm so bad at assembly. What are we doing? Mem set, mem copy, shuffle registers. What? Yeah, the problem is I know nothing about how we generate assembly. Not nothing, but I don't know the utility functions I could use to tell the one which, like, I don't know what any of these functions do. This has totally not been my area. But we'll figure it out. It's just gonna take way longer than it should. Okay, so it has to be an X or an A, whatever you call it, an A, not an X. It has to be an A, and the other one seem to be any registers, right? So we would say we need A and 2 temporary registers. So I say spill racks. Not sure what vreg prepare does. But we'll have a look. Seems like I have to do this. And I need R, I need pointer, I need old value and new value. Okay. So I should have the values of those somewhere. Afterwards, I spill the one I want, which is racks. I don't know what shuffle registers does. And the problem is these are not documented, of course. Do we have anything here? No. Yeah, what, like, my problem is I have no, I can't even build hypotheses of what these things are doing. Like, destination, source, count, and spill skip. I don't think I want that in this case, right? So I need to find something that needs a particular register and then random registers. I'm just gonna go by pattern matching, basically. Yeah, move has no constraints. I need something that has some constraints. I'm trying to find a instruction that's close to what I need to express, and I hope that it exists. Something that needs a particular register and random registers. I can't see this right now. Or maybe this is something you don't need. Maybe the vrec prepare already does this to a certain amount. Maybe that's why I'm thinking wrong. So vrec prepare moves them into real registers. This already picks temporary registers. Okay. That would mean maybe I don't put the pointer here because I want the pointer in racks. So how is a structure with an array in it not 16 bytes? No, this was a fixed sized array. A fixed size array knows how big it is. You don't need a count. The count is a constant that's inserted by the compiler. So you only need the actual data. A fixed size array is as big as the array would be. You mean array views? Array views are 16 bytes. But they consist of a data pointer and a count, whereas a fixed sized array contains just the data, no pointers. What are we doing here? Okay, let's go from the top and try to find a simple thing that spills. Yeah, I need to know more about assembly to understand this. I'm afraid. So the P's in binop. Okay. So we take all the registers, we put them into P. We say vrec prepare. This is the destination register. We pass that. Okay, we ignore that. But P0 is the destination register. And VA, VB. So P1 is VA and P2 is VB for the binary operation. Okay. And then for division, we say if the destination register is not RAX, we spill RAX. If the destination register is not RDX, we spill RDX. If it's not RCX, so we spill all three. If destination register is something random, we spill all three. Why? And then I take REX and RCX, not RDX, and I call shuffle on them. With P0, which is I wish these were named differently. If you're well versed in assembly, this is probably totally reasonable. For me, it's gobbledygook. Why are we doing this? And what is this one doing? So I pass in REX and RCX and whatever P0 is. And then I divide, I do an interdivision into output. What's output? Where the f is output? Where are you coming from? Is this something in the x64 converter? Oh, that's the concatenator. Okay, never mind. Okay. So where is it? Integer division. Then we add an integer division to output. Okay, the integer division takes operand 1, size, and sign divide. So operand 1 is RCX, size, and whether VA is signed. How do I know that the A operand is an RCX after this shuffle party? Oh, I guess the integer division is so it's RAX divided by operand 1, and the result is in RAX, and RDX gets also something. Okay. Why does RCX though? RCX is not involved, right? So we have D and A involved, but C doesn't show up here. So why is C hard-coded here? Like, what's the... Oh, we always use... Never mind. We always use C as the second operator. That's why. So that's why AX and DX, like, or I should just say A and D. A and D are what's modified in the integer division anyways. So I still don't fully understand these two, honestly. If the result register is not rex, we spill rex. Yeah. But why does it depend on the result register if we have to spill RDX and RCX? That I don't understand at all. Seems like you copied the block up to shuffle registers, then do the cast instead of the diff. I can't follow you. Ian. Like these two lines I don't understand. Why do we only check what's in P0? Here I pass in letter to registers and the first one, and I guess what I'm yeah, I don't get it. It's weird. Maybe I need to just look at this in the debugger and see what's happening. But it's... It is, we don't need to spill the destination register because you're just overwriting it. Oh. Thanks, Ian. Yeah. Okay, so if the destination register is RDX, we're going to copy into RDX anyways, so there's no need to restore it afterwards. Ah. Sure. I was trying to read into it. I was like, the result is always going to end up in rex. So why, like, if the destination is RDX, but yeah, that's... Yeah, thank you, Ian. Yeah, that makes total sense, because here we then move, so the result of the integer division is always in rex, and here we do a move to whatever the destination register was. If this is rex, it's a no-op. If it's dx or cx, we write over something that we used, but then there's no point in restoring it afterwards, so that's why we don't spill. Yeah, okay. Spill means save on the stack and restore it after the operation. Okay, so this one makes sense. This one, less so. I don't understand what it's doing. We skip, okay, so the last one is spill skip. So we basically say, I don't know what it does, but we pass the two input registers, P1 and P2, and we say ignore P0 or spill skip D0, whatever that means, and destination is rex RCX. Let's see what we do there. And then we say if the next one, so we look for the rest of the array. So we look at the first one, source and destination. So, okay, so what we're saying here is P1 is compared against rex and P2 is compared against RCX. because we want, for the integer division, we want the first argument in rax and the second one in RCX. So what this does is whatever you used to copy the bytecode registers, you copy them into some registers. Now move things around so that the first argument ends up in rax and the second one ends up in RCX. And please don't use whatever our destination register is. And you might use RDX. We've spilled it. But it's going to get overwritten by the operation. Okay, so what we're doing is we say if why are we using a U32 for a Boolean? Because we're assigning it here. Why is this a U32 if we then assign it to a U8 register? Like, what? That seems deliberate. Do you see this? This should be U8. It should be whatever, but should be a U8. It should be a Boolean, but whatever. I think just copy that entire block and replace the IDIF with your compare and swap. Depends on the registers. Like, I don't think we can do the same because this one has to use these 3 registers, whereas we are free. Like, we care less about which registers, because if I read this one correctly, like rax, so A is involved, but all the others are not. Like it's not fixed what the other operands are. So it's not the same as this one. I can copy it, but it would be, we need something slightly different. So we don't need the shuffle registers. So I think with this, so you're right, we're gonna start here, but I think our operation is quite different. And, but you know what? Oh, come on. Yeah. We're gonna do, so we have our destination and the 3 operands. And then we say if the destination is not rax, we spill rax, right? That's the same. And then these we don't care about. Whatever the other things we've picked, we don't care. And then we do log comp exchange output. Maybe we have something for output in the log separately. Probably. We'll look at that. And we give it P. No, we have to move P1 into rax, right? This one. We need to do this. We need to move the pointer register, which is the one that gets, yeah. Okay, so we move the pointer, so we spill rax. We move the pointer into rax. We don't want to use the destination register for that. Then we know that Rex is going to be involved, so we need to pass in P2 and P3. Those are the variables. And the size. And the size we get how? Register size, okay. So then we do blah blah size. And then we move Rex, which I guess gets the result. No. We don't get the old value. If the values are equal, the second operand is loaded into the destination operand. Otherwise, wait. I think I got the order wrong. Compares the value in A with the first operand, which is the destination. Oh, I got this wrong. If the values are equal, the second operand is loaded into the destination. Otherwise, the destination operand is loaded into Rex. Okay. So Rex always contains the old value. If it's the same, it's fine, otherwise it gets overwritten. So Rex, okay, this is fine. Except that I shuffled the order here. I want the old value in Rex. So the old value is 2. I want the old value in Rex, and I don't want to stomp over the destination. And then comp exchange takes the destination and the new value. And then we either have the old value in Rex or whatever was in the destination register, and we move that out. Okay, so this is fine, except we didn't implement the encoding of this one. Yeah, I get your point, Ian. I didn't do it that way because I wanted to fully understand. I don't know. I think your approach might have been faster, but it has bothered me for a while that I don't fully understand what the x64 instruction code was doing. So I just had an urge to get a bearing of what's happening before I just copy pasta and fudge it until it's right. It's still gonna be iterative because it's still not gonna be quite right. Hey, cakes and people, friends of cookies, hello. We're doing interesting stuff that's totally out of my comfort zone. Okay, but I think this might be fine. We'll see. We'll have to look at the generated assembly very definitely. So let's see if we have something that outputs lock. F0. If we look at the assembly, like if we do the, this one has it in spades. So if we just execute this one, log I, just, can I also see the bytes, please? Debug workflow, I think. Could you also show me the bytes? That would be so nice. Okay, I think LDB can do it. Tests, features, intrinsics. Does someone know how to tell it to show me the actual bytes? Because I don't know. I have another idea. Tests, features, build, intrinsics. Yeah, here we see the bytes. Hooray! So we look for lock. It's just F0, literally. And here we have one of the complex range encodings. Okay, nice. So we go here and we do lock output. And we might have that already. Maybe we have it. Doesn't look like it. Do we have F0? That's not something great to look for. Does not exist. Not at all. Interesting. Okay. So where do we put this? C, add unsigned 1 byte. F0. That's it. And then we do the comp exchange. Like cakes in every stream. How was your stream, Cakes, if you're still here? Or was this a raid and run and I didn't ask fast enough? How was your stream? What are you working on right now? Are you procrastinating or working on your game? So we expect destination. And in size. He's working on 2 games. Yeah, because working on 1 game isn't interesting enough. Not demanding enough. It's not taking long enough time. A Jai project. Nice. How is he doing with Jai? Like, is he struggling or is it working fine? Okay, and now we need to figure out what all of this is doing. What is getRex B? What is getRex? We have a ton of utility functions and I haven't used them here at all. So we can just do here assert size is 1 or size is 2 or size is 4 or size is 8. Just to be safe. Doesn't have a round function. I'm pretty sure it has a round function, by the way. But hey, Big Fox. Maybe it doesn't actually. I mean, we have the yeast, but that seems weird. Nope, no round function. Okay, let's look at the encoding of comp exchange. Lock was easy. This is going to be less easy. So depending on the size, it always has OF in front. So it's always locked comp exchange. Looks like it, right? Or was it, or is lock FO? Lock is FO. Lock is F0. Never mind. I'm bad at this. So we have OF. I can't read these encodings. Oh no, what do we do? So we have get rex. I'm sure this makes sense to someone. So get rex does it for R and M. It could be any. It could be any registers. So I understand we have to, like, my understanding is limited to, I know we have to do this. And that's not even complete because we have to merge in the rex. Maybe this one, the problem is this is all things, if you learned assembly ever, you would completely understand it. I haven't learned that, so I'm flabbergasted. We could do, like, mauve is a too flexible instruction. What kind of instruction could we look at and compare what it's doing? Maybe something like neg. Let's look how neg is encoded. I'm learning. This looks too simple. Maybe let's pick something more complicated, but maybe we can still get something from this one. So it's F6 or F7. Okay, yeah, F7 if it's one mode minus minus. Yikes. I would have said, whatever. Like, I would not have expressed it like this. I would have said as mode is F6, but that's just me. Like, why do it relative if It probably whoever wrote that, yeah, but I wouldn't. I don't know. I want the explicit constants here, if they're constants, and don't use the fact that they're close to each other. You know what I mean? So we have x6, f7, which we write. So how is the reg? Rex is reg B. If size is 8, we add the W. Okay. But then how is rex used? It's first. So rex comes first if it is set. And if size is 2, we add a 16-bit. We add 6, 6, which is something I don't see here. But the rest is kind of fine. So if rex is set, we add it. So this means it's an extra prefix byte. Then we do f6 or f7. And then we do mod rm 3 op. Okay, I guess that has something to do with the 3. Let's see, what does mod rm say? It's mod and r. And the register is the last one, so M is a register. So mod is shifted in, and then register is masked and shifted in, and then M. So these are moved into one, these are merged into one byte. How do I read that from this encoding? Unit rex only if operand 64-bit or if you use. Yeah, this is with this one determines. That's what this is for. Also, X-bit ops have a 16-bit prefix, doesn't appear in the docs. Okay, thank you, Big Fox. Thank you very much. So I'd have to do this one as well. Thank you very much. Thank you for being here. Yeah, I'm not using it to learn assembly. It's just you can look up the encoding of instructions and what they mean. It's not enough. Clearly, as you see by Big Fox's answers, clearly it's not enough to learn assembly. But it's good for looking up encodings. Except that you have to know the notation, etc. Oh, you see here operand encoding. Mod RM, RM, RW. Okay, you know what? We need to look this up. We need to learn, like, it's not enough to just go by the symbols. Explicit operands encoded with the mod RM byte are MR for the RM or reg field. I think I just have to do some reading. This is not enough. Like, all of this expects more knowledge than I have. Maybe I should have followed Casey's course further. I'm 6 months behind or something. But I guess I would learn that in Casey's course. Let's just close this stuff because we figured this one out. Yeah, what I did not understand is here we're doing mod RM 3 op, and I don't know what 3 and 3 are. They are marked as mod and R, but I don't know how from this table I realized that the 3 and 3 have to be the first two ones. So that's what, you know what I mean? It's totally clear to anyone who's probably learned assembly, but since I'm not one of them, oh, I even remember that. Casey went over that, I think. I think I need another coffee before I tackle this one. I can probably get it to work by just squinting at the code and copying from others, but I don't fully understand it. And I'm missing... Thank you. Oh, okay. So if we know we're doing register, so that's why we put in 3 for mod. This gives us the register, which we know. A second operand. I see. Yeah. So it even says the one is in RM, the second one is in reg of mod RM. Okay, perfect. So with that knowledge, let's give it a try. That one can basically go in here, and this is bytes. If we want to do unchecked, why can't we do unchecked here? That seems weird. Why can we do unchecked here? Who prepares the concatenator to eat an unchecked number of bytes? Oh, we ensure space 64 bytes before every instruction, so that's why we can do unchecked. Okay. Unchecked basically, so add 1 byte, sees if the concatenator has enough space, like any of these add functions, except the unchecked versions we don't check if there's enough space. So if we have 64 bytes for every single instruction, which seems very excessive, just make sure that 64 bytes are available before we start any instruction coding. Yeah, except all of these are a bit special. But we can have a look at. So this is what we had. We get regs. So it could be, so we said destination is the first argument, new value is the second argument. So here we would say, basically this one where we have new value and destination and the size. Okay, then we have the 16 big thing. Then we have the regs part. That one we don't care about. So that gives us this part. And then we just say this one, mod rm, 3 for register to register mode, and then we said it's R and M. What? No. Mod RM. But isn't that misnamed? Oh, just RM is M for him. So that should be it. I think that's it. But cliffhanger, I'm gonna get a coffee and then we'll try it. So Big Fox says I'm missing B0 or B1 depending on the operand size. What? You are right. Although I don't. Yeah, it's either EFB1 or EFB0. What is the /R though? Does this mean that the register is encoded in this byte? I can't read this stuff. Like I just don't have the vocabulary. What did it look like in our case? In this one. So we have a comp exchange here with D and C. So this is the destination. Wait, why do we have the address? So we have an indirection here, no? Oh no, sorry, we are we're in AT&T syntax, so this is the destination. So RCX contains the destination. So destination pointer is C, D is the new value, and A of course contains the implicit one. So we have B1 in this case, because it's a 32-bit version, I guess. And so it's just B1. And then we have 11 in the next one. Why 11? This is the mod RM, right? Yes. And if we look at this one, so RM is 1, reg is 3, no, reg is 2, and mod is 0. So it's a register indirect addressing mode. Reg is D, and RM is C. Is that what we see here? D and C. Yeah, and C is indirect. Right? So we don't put 3 in because we have the pointer in the okay. So this one is 0. Right? Give me a second. This is the mod. Yeah, mod is 0. Destination contains the address. I still have a problem. Why is this not called RM? Isn't this the RM? Let me see. Yeah, so what he says M is actually RM, and R is the reg. I would love if this was reg and RM. I don't know about you guys, but I think I'm gonna change this. like we can save a couple of characters. Like we can afford a couple of characters to make this actually read like what the encoding wants. Huh? Okay. So with that, we have to say 16-bit comes first, we said. Then comes rec, then we say wait, it's always 2 bytes, right? It's always B0, B1. Okay, so we say, let's change this. If size is if the size is 1, then we have B0. So we say U8 B2 or is hex B1. That sucks. What do we call this? You know what? Just because everything here is hard to read, doesn't mean we have to continue like that. Instruction byte 2. If size is 1, instruction byte 2 is B0. Right? Then we say instruction. Like I'm fed up with having to decipher this. We can use verbose names. We can afford that. Okay, so we have OF instruction byte 2, mod RM is 0 actually, and the register, man, this is D and it's indirect. Give me a second. No, RM is indirect. Give me a second. Register indirect addressing mode. Okay. And this one determines the source and destination. And this is a bit much for me initially. In our encoding here, RCX is definitely the destination and it's the indirectly addressed one. CX is RM. So RM is the destination and indirectly addressed. That's the one stored in RM. Okay. That's how we encoded it. Yes. So I think this might be fine now. We have the extra. Assuming that the Rex part is fine, which I'm not completely certain about, but we'll try. Yeah, this no longer exists. This is comp exchange. And we give it destination, ding, and size. Okay. Okay, let's just try this. Fingers crossed. Do we generate something valid, or is the link already complaining that the assembly is nonsense? No. Okay. So let's go over here. You know what? Let's do it in a separate window. And wait, why is there not no intrinsics.o? Did we barf? Oh, because I'm a moron and didn't use the x64 backend at all. We didn't barf still. Shall we just try to run this and see how badly it... Safety squint. It's gonna fail. Like, no way I got this right on the first try. No way. Yeah, that doesn't look too good. Okay, I'm not a wizard. Good, good. So let's see what we barfed out. This should be in comp exchange tests. There we are. We call a lot. And I don't see a single lock or comp exchange here. Okay, let's figure out what's supposed to be the comp exchange. I don't even see an F0. So this completely, I botched this completely. Oh no, wait, this is actually, this is not inlined. So we should see, yeah, we have different version of the comp exchange test. Never mind, we'll just have to find these. Okay. Oh, that doesn't look too bad. I see a comp exchange and comp exchange. So we have a quad. Now we have to figure out which one is which one. Okay, let's go back to this one. The first one we call is this one. So this is gonna be the Boolean version. The Boolean version says comp exchange byte RCX and BL. How do I figure out if this is the right one though? But it's like generally this doesn't seem completely wrong. We put the result in RCX and then we move RCX into rack. So this is actually the destination register we wanted. Whether BL is the right one, I don't know. 352 of RSP. Where do we store the arguments? 352 of RSP doesn't look good. Here, we move AL into 352 RSP. Yeah, that seems not completely unreasonable. And we moved RDX. It's a quad move. That's a bit strange. We move the byte and then we move a quad. Well, okay. So 44 and 52, that seems to be the two arguments that were passed. We do a bit too many moves for my taste, but so from 32 and from 40, yeah, this it doesn't look completely bonkers. Yeah, no seg fault, but also the infinite loop means we're probably hanging in the initialized thing because we're not doing the comp exchange correctly. Like I'm almost certain we didn't see anything because this one, this while loop, I bet we were stuck in this while loop because we're not doing the comp exchange right, so we don't get the right value, so we don't break here. Like, I'd bet. And we can just try it, of course. See? So we do a long comp exchange. So I think we got the encoding right. Maybe we messed up how we copy the operands into the registers, but the encoding seems all right. So old is 0, new is 1, destination is blah. If we look at destination is 1, so we should get back a 1, right? And if we now see what's actually happening, Rax is 1, RCX, RCX is 1. Yeah, old value is 1, current value is 1. That seems fine. But old is something, as you can see. This is not supposed to happen. So we're messing up the return value extraction. But it's not as bad as it could be. Like I thought it's going to be worse. So for some reason the P0 stuff is wrong. We wanted to move Rax into P0. What did we actually do? P0 into Rax? Are we though? No, it doesn't look like that. Like this mauve is destination first. So we're moving Rax into P0 here. We're gonna look at it here. Let's disable that breakpoint. That's not necessary. We're gonna loop. We're gonna break. We're always here. Let's look at the disassembly again. We comp exchange, yeah, but we're moving wrong. We do comp exchange long, and then we move this into Rax instead of Rax into that. Ha! But this one says destination source. And we're saying, please move from Rax to B0, but that's not what we're outputting. Why? Right? Or am I blind? We're immediately stomping over the result in Rax, which is the old value. if we go here, man, first times are hard. If we look at this one, like everything on macOS by default uses AT&T syntax, so destination is on the right. This is why if you go here destination is right. So here we're moving into racks. We're stomping over racks right after the comp exchange. And we can see that if we go single instruction, blah, blah. And then we say, show us everything. We should have racks is 1. And then we just do smash. So this one is wrong. And it comes right after comp exchange. So clearly there's something fishy going on. What is P? P0. P0 is 0. What is racks? Racks is 0. So we're not doing anything because it's already in racks. And we didn't spill racks because we overrode it anyways. Right? Do I understand this correctly? Oh, you know what we forgot? I think. Give me a second. Yeah, we didn't write the result. We moved the result into racks, but we forgot to write it back into the bytecode register. That's what's missing. So actually, yeah, we could write directly, honestly, like, why are we moving this via racks? Like, this seems silly. Why are we not just moving racks into this one? But that's how everything here does it. It seems stupid, but there must be a reason. You will always go from blah to P0 and then from P0 to this one. That seems like it could be improved, but that was the bug. So we didn't have a move to racks because we picked racks, but then we didn't move it back to we didn't save it actually. Okay, so if we try this one, and just run it. Safety squint. Nope, still doesn't look good. So long. Rosetta usually doesn't take that long. Oh, I know why. Because I didn't recompile. I only recompiled an Xcode, but that doesn't recompile our CMake version. Clang assembler accepts measurement. Yeah, you mean not the assembler. You mean the. Ta-da! Yes, I did the comp exchange encoding right the first try. Well, with your help. Like, I would have missed the B1, B0 part. I would not have known about the 16-bit operand without you. So thank you very much, Big Fox. But apart from that, we did it right, yes. But it took forever. Anyways, we have a comp exchange. We have a lock comp exchange, actually. In the x64 converter. It's working. That's pretty nice. We have it templated. Templated. Ooh, bad word. It's a polymorphic version. That's what I wanted to say. Which means all of this can go to hell. So we don't have the 16-byte version implemented right now. Okay. This is no longer incomplete, but weird if we hit it because we implemented everything. So I think this is just now an this one. And also I wanted to see this one. We never hit this one. That's interesting. So I'm gonna drop it for now. Yeah, that cleanup I'm gonna leave. We made this slightly more understandable, which is nice. Oh, let's try we didn't try the compile time version yet. Oh no, another chance to fail. Engage safety squints. Boom! No, I messed this one up. So bytecode runner is unhappy. Let's see, what did I do? Yeah, this one is wrong. This one is wrong. $32 is just here. 16 is just here. 8 is just here. Yeah, looks right. 64 is just here. Okay, let's try that again. It's not gonna save us, I'm afraid, but yeah, now we need these 10,000 versions. Ugh. Why is this one void? Oh, it's void pointer. Never mind. 'Cause we have the Unix version, but we need the Windows version. Oh, hey Thorglebit, thanks for the raid. Haven't seen you in a while. How are you? Oh no, I missed him. Yeah, we're winning, Thorglebit. I'm sorry, I'm focused because we're winning hard. Like, it's looking good. But enjoy your food. Probably needs suffixes. Thank you, we'll see. We still haven't gotten the macOS version working, so byte runner. Let's see what we did here. Boom, 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 boom. Maybe let's do it before the comp exchange. Okay, so we have old value 1, new value 0. What? That sounds wrong. But I don't know. And pointer is... And we're hitting the U8 case, interestingly. So it is 1. We say old value 1, new value 0. So we are replacing 1 with the 0. And afterwards, we have a result of 18, which clearly is gobbledygook. Yeah, so this one is broken. Compare and swap. We give it hopefully the right one. Let me check. The pointer is 518. No, this is broken. We're doing one in direction too much, I'm afraid. We should give it pointer, but we're taking the address of pointer. That's wrong. Right? Yeah, that's nonsense. This is already a void pointer, and it... give me a second. We should pass this in without anything. Like, we just have to probably say... where do you put the volatile? Give me 1 second. I'll be right back, and I'll think about it. Well. Okay. So this is clearly weird. Here the double pointer makes sense. Here it doesn't quite. We pass in pointer. Yeah, this is wrong. Wait, we had... This is already the address to where we want to write to. We need to pass this in like that. Why are we using this otherwise? This is all nonsense. Yeah, this is complete nonsense. We had one indirection too much. Which means this one has to be... Is this a thing? Let's give this a try. Does this compile? Nope. And now, okay, never mind. And now we say this is a pointer to a void. Here. but we don't take an extra indirection. That was wrong. And now let's try this. This is 1, we go in. Test pointer is still 1. Yeah, now it makes sense. And now result is 1 and we're happy. Okay, I'm just too stupid to program in C++. That's all. And now we just work. Except for the internal compiler error I just did. Number flags is 0, so now it's the pointer type, isn't it? Isn't it? The thing that's the case I just threw out. BC debug expression. That's not good enough to know what's going on. Yeah, in the debugger this is a bit hard, but let's go. Where's the bytecode runner? Give me the bytecode runner, god damn it. So let's undo all of this. So I want to get this back. That was correct. That's the one we just hit. Ta-da! Let's see what else we messed up. Oh no, wait. Let's first do this. Okay, good news. That means we have removed the requirement for WASM 64. So inline assembly, x64 inline assembly to do compare exchange, which is a big step towards making things work on ARM and WASM. We didn't get to actual WASM today, which is a bit sad. But I'm happy that we finally got rid of this one. It took too long for my taste, but it also, this one was on my list has been on my list for a very long time. So getting rid of that one is super yummy. We have to check it on Windows. As Big Fox said, I probably need where did he say it? Probably needs 1632 suffixes. You meant for atomic compare exchange, right? These ones. Oh yeah, totally. 32, 16, 8, I guess. So these are actually equivalent. We could get rid of one of them. We probably should. Regarding ARM support, is there a plan to add memory ordering hints to the compiler? Seems an important feature to correct authoring for CPUs with weak memory ordering semantics. I have no idea, Big Fox. This is something you clearly know way more about than I do. Like, I don't know anything about ARM. I've never seen a single ARM instruction that I could decipher. Like, I've seen it by accident when I accidentally debugged an ARM version of something instead of an x64 version. But that's really, that's it. I've never seen, like, I have no idea about ARM. Zero. So I am not going to be the one that writes the ARM backend. Just saying. Okay, so this one we've seen before. This popped up now a couple of times. It's solely unrelated to what we did. Okay. So let's look at this one. So we have the run in AppKit and the run in module. This is just bad timing stuff that's surfacing. So we have 367. What? No, 56, and here we have 367. So this one is trying to create Objective-C class member stop for NS Windows controller, and here we have init Objective-C selector struct. Okay, and this one can't finish. So this is totally luck dependent, basically, if they run in the right order or not. Oh. Yeah. What do we do about that? It's easily fixable by just making all of these stallable. And it's perfectly fine for this one. But maybe we find a better way to express this in the future. Oh, this is Buddy dead? Buddy is dead. Oh no, Buddy. We didn't have Buddy for the whole time. Hey, Inest, try again. I'm not sure if we have help. Do we have help? I don't think we offer help. Maybe we offer help. Yep. Okay, I think I'm gonna stop here. Even though I didn't get to where I wanted to go. But it is geo practice time. I'm not quite sure if I can go because like depends on the situation outside, the family situation, but either way it's time to stop. Either because I have to go to geo or because I have to like relieve my wife and take over the kids. But this is good progress. It's a start. You know what we're going to do as a final step? We're going to run this on Windows and just verify that it's working. If it's not working, I'm still going to stop, but then I know that there's more work to do. Yeah, now this one can actually go away. This commenting out of one time init, because now we have a compare and swap. That's fine. Right? The only thing here is we have to say if CPU is x64, then do this, else like this is 5 as instructions. If I say slit milliseconds 1, it's gonna be awful. So do you do sleep a bit maybe? We're just busy looping. Sorry. But this is way less bad than throwing away the whole procedure. Okay. This is where we're gonna push, and then we go to the terrible Microsoft land. Oh, by the way, Braid got announced just because like Sharkbody talks about some of the other John's other projects that need to get done. That's one of them. Okay. My feeling is this is not gonna work on Windows yet because I do something stupid somewhere probably, but we'll see. Maybe I surprise myself. Also, we didn't run the LVM version of the tests here, so this might also give us a nice surprise. So let's do the LVM version while we do. No, interlock compare exchange doesn't exist. From void volatile to volatile short. Oh, did I mess this one up? We'll see. Looks like I messed it up. JIOS specific. Compare and swap. So pointer does pointer 16 and 8. Oh yeah, I need to cast those. S32 volatile, S16 volatile, character volatile, whatever. It's still not gonna compile because of the interlock compare exchange 32 doesn't exist. Maybe it's the default. I don't know. Let's just look it up. I don't need the casts. Maybe you're right. You are right. That's already the data we have. Why are we doing this? This one needs it. Okay. Interlock compare exchange 16. The other one just has no prefix and no suffix, I mean. All right. That's good. Oh no. What's your problem? Let's do it here so we get nice error messages. No, 64 does the pointer. Yeah, do you show me the 4 overloads or not? Can I see the overloads? Ah, fork you. Long, volatile, long. So why are we not fitting that overload? We have sine 32, which is long, isn't it? I mean, it doesn't show me the overloads, of course. Okay, here we see it. Can I see why this one is not being used? I don't see the problem. I mean, I can do the stupid stuff and say long volatile pointer and see if that fixes it. But in my understanding, that should be the same, no? It's not? Are you kidding me? But isn't... This one worries me because it means that S32 and long are not the same. But aren't they on Windows? Am I going crazy? It's weird, isn't it? Let's do the x64 version first. It's gonna fail faster. This one passed. That's good. Int and long are different types, even if they're same size. Yeah, but I didn't declare that int. I declared it as signed32. That should be equivalent to a long. I didn't say int. This is signed32. Whatever. No, signed32 is S. It's you see, it's int 32t. That's not int, is it? That's the more specific type. Long is defined to be long. Yeah, okay. No, Mendoza, that depends on what decision the platform made regarding... I looked this up 5 times, I always forget what it's called. But on some platforms it's long, and some platforms it's long. It depends on what kind of 32 to 64-bit extension version they picked. It has a name. Don't ask me. This is the kind of thing. I just get angry about it when I hear it, and then I forget it again. And I know that from macOS, Windows, and Linux, one of those picked a different extension version than the others. And I can never remember which one is which. And it's not even called extension. Don't ask me. Like, seriously. It makes me angry. This worked. Let's do this one as well. This is a fix-up, by the way, that we have to merge down. But this looks good. It's just the first baby step towards better WASM support, but it's an important one because this is something you could not really have done. Not really. You could not have done this in the meta program. So this is a valuable one. Most of the other things we're gonna do, you can probably do in the meta program. This one you could not have done. So that's a good first step. We're gonna do the rest. So let me think. I'm not sure if I can do it tomorrow. I'm not sure how I'm gonna like shuffle the projects this week, so that it makes sense. Friday, something else. Tomorrow or the day after, I have to go into the office to talk with my colleagues, co-founders. We'll see. Maybe we'll do the rest on Tuesday. Otherwise, on Wednesday. Yeah, I think the rest is, like, I have to talk to John about it. I'm not sure how he feels regarding shipping WASM stuff, but I think it would, since many people are trying it, maybe it makes sense to have a how-to in the compiler about how to do WASM as an example of how to do non-x64 platforms, and then maybe take Patrick's WASM plugin and just move it into the compiler. Maybe. And like clean it up a bit, generalize it a bit, etc. Maybe not. Maybe it's too much of a foreign object for the central distribution. I'm not sure yet. Well, first we're gonna make it work, and then we'll think about how much of it we're gonna bundle with the compiler. Maybe we just add a how-to that references the external module. But then again, if we kind of depend on it, maybe we should ship with it. I don't know. I really don't know. Like, WASM is a good example because, like, what other non-x64 target could we reference in the how-to or in the examples that people have access to? Like, everyone has access to WASM. If we do something like, oh, this is how you target iOS on M1, like, that might be useful, but it's not going to run on Windows. It's not going to run on Linux, because you don't even have the toolchain to do the remaining steps. Like, but WASM we could do out of the box without shipping extra dependencies. So that's why it might be an interesting example of how to do non-x64 stuff in Jai. Just a thought. Anyways, this works. We did good work. I'm going to stop here for today, or at least for the stream. Thank you very much to everyone in chat who helped. Like, thanks again to our special guest Kuyu, who phoned in initially and gave me a general description of what's the state of WASM in Jai. Thanks to Patrick for working on the Jai WASM plugin, which we haven't used yet, but we're gonna do next stream. Thanks to Mox and Big Fox and all the guys who helped me with the assembly stuff. I appreciate it. I'm out for the day, but we had 2 raids. We have to pay it forward, right? So let's see. Whom shall we raid? We can raid Mr. Pilot Software, of course, but he rarely does, like, he's an interesting guy, but he rarely does interesting programming on stream. At least I haven't caught it. Like, his anecdotes are interesting and his stories. I haven't seen him actually program. He mostly modifies text files for Minecraft. Am I right? Am I wrong? Did someone see something else? Yeah, Pirate has plenty of viewers, that's true. On the other hand, who does interesting stuff and is small? I'm open to suggestions. Yeah, I've raided Johnston quite often. He usually does Godot, so it's I'm not sure how much it fits our audience, but at some point we have to raid one of these look at me while I program people, or maybe this one. No, I've never done any VHDL work. I have a friend who's really into the depths regarding like electronic engineering and all these like oh god, what they're called. I'm blanking. Where you need VHDL for? What do you need VHDL for? What are they called? FPGAs, right? Yeah, someone said it. FPGAs, yeah. So who did all the FPGA stuff and lots of electronic engineering? Like one very good friend of mine is deeply into that and really good at it. But I don't know anything about it. Well, yeah, like but he also does like all the, I don't know. I'm not a fan of having all that crap on your screen, but as you can see from my stream, but clearly it's working. I don't like it. Okay, let's go with Jotson. I've rated him a bunch of times. He seems nice. I'm not sure how applicable his work is, but I mean, how interesting it is to our streamers, but our stream viewers. But you'll see. Alright guys, have fun with Jotson. I'm out. See you next time. Bye.